section, we will take a look at the sum and difference formulas for tangents, very similar to the work we've already done with sine and cosine. You can see those versions are listed here, tangent of A plus B, so if we have two separate angles, A and B, tangent of A plus tangent B over 1 minus tangent A tangent B. Obviously, you'll notice those are a fraction, which does complicate our work a little bit as far as simplifying some of these answers. But also notice here, this is tangent A times tangent B, and I'm hoping we all know in our order of operations we will multiply those together before we will subtract those from 1. We don't take 1 minus the first term and then multiply it by the tangent of B. We take the tangent of A times the tangent of B first and then subtract it from 1. And then tangent A minus B is also listed here, tangent A minus tangent B over 1 plus tangent A times tangent B, again noting that product right here. A couple of quick points here about our sum and difference. If we have a sum here, we're adding two angles together. Notice our numerator has a sum, our denominator has a difference, and vice versa here with our difference. We have a difference in our numerator and a sum in our denominator. Other than that, we're still using our unit circle, and that information should allow us to simplify some of these like we would sine and cosine. So we'll jump straight into here to our first one where it says a tangent of 75 degrees. Off of our unit circle, there are other combinations we can come up with, but probably the easiest out of the first quadrant, 45 plus 30 would add to be 75. So we'll write that as tangent of 45 plus 30, and then expand that out in the tangent of 45 plus the tangent of 30 over 1 minus the tangent of 45 times the tangent of 30. So there's our formula. And now we'll take the values off of our unit circle and plug in there. The tangent of 45 is 1. The tangent of 30 is the square root of 3 over 3. 1 minus the tangent of 45 is 1, and the tangent of 30 is the square root of 3 over 3. Now from here we do have a couple of different directions we can go. The best of which, at least in my opinion, is to work with the fractions as little as possible. So I'm going to take the two terms here in our top, or our numerator, and write those as a single fraction, and that would be 3 plus the square root of 3 all over 3. So 1 is 1 over 1, common denominator 3. 3 plus the square root of 3 over 3. I'm going to repeat the process for these two terms in our denominator, noting that I'm taking 1 times the square root of 3, so that's essentially 1 minus the square root of 3, so my denominator would be 3 minus the square root of 3 all over 3. And once we have that, it does give us an extra step, but it also does help us simplify a little bit easier, because when I multiply by the reciprocal, I hope we would all agree or can see that these 3's would cancel, and now I have 3 plus the square root of 3 all over 3 minus the square root of 3. In other words, I no longer have those fractions to deal with, which will make life simpler for most of us. From here, we have to remember back to our days in Algebra 2 and understand, first of all, that we can't, a simplified fraction cannot have a radical in the denominator. And then secondly, to remove that radical from the denominator, we multiply the numerator and denominator by the conjugate of the denominator. So there's a reason way back in Chapter 5, early in Chapter 5 I guess it is, I talked about the conjugate idea to remember that process to rationalize your denominator. So I'm going to multiply the numerator and denominator by the conjugate of my denominator, meaning I change the operation in between. 3 minus the square root of 3 times 3 plus the square root of 3. And if you recall, when we multiply or FOIL with conjugates, the outer and the inner will cancel each other out, so we can just do the first and the last. So first term's 3 times 3 gets me 9. Last term's negative square root of 3 times the square root of 3 just removes a radical, so my denominator is 9 minus 3. Also noting there we accomplished our goal of removing the radical from the denominator. In the numerator, I will go ahead and FOIL those since they are not conjugates. They have the same operation in between. First terms, 3 times 3 is 9. Outer terms, 3 times the square root of 3 is 3 square root of 3. Inner terms is also 3 times square root of 3, so it's also 3 square root of 3. And the last term, the square root of 3 times the square root of 3 is just 3. So there's all four terms from our FOIL process in our numerator, 9 plus 3 square root of 3 plus 3 square root of 3 plus 3, and we're still over 9 minus 3. So here, I'm going to go ahead and combine like terms with my numerator. I have a 9 plus 3, which is 12. 3 square root of 3 plus 3 square root of 3. We're adding the coefficients there, so it's 6 square root of 3. And my denominator is 9 minus 3, which simplifies down to be 6. As you hopefully notice here, we do have some more simplifying we can do because 12, 6 square root of 3, and 6 can all be divided by 6. So I'm going to divide through. 12 divided by 6 is 2, and 6 square root of 3 divided by 6 is the square root of 3. So the tangent of 75 degrees is 2 plus the square root of 3 in simplest form. Gets us through our first example. Notice number 2 is an angle and radian measure. For most of us, it's probably easier to find 2-degree measures that add to be that number rather than 2 fractions. So I'm going to go ahead and change that to a degree measure by multiplying by 180 degrees over pi. The pi's will cancel here. The 12 and the 180 can both be divided by 12. So 12 divided by 12 is 1. 180 divided by 12 is 15. So that's going to give me the tangent of 105 degrees. We go to our unit circle. Again, we have options. If we use angles out of the first quadrant to add to get 105, we could add 45 and 60. We'll expand that out again as a sum, tangent of 45 plus the tangent of 60 over 1 minus the tangent of 45 times the tangent of 60. Going to our unit circle, the tangent of 45 is 1. The tangent of 60 is the square root of 3. 1 minus the tangent of 45 again is 1. The tangent of 60 is the square root of 3. So this time we don't have that fraction to work with. We simply have 1 plus the square root of 3 over 1 minus the square root of 3. The process, however, is pretty much the same. Notice we have an expression, a sum or a difference in our denominator, in this case a difference. So to get rid of that radical in the denominator, we have to multiply by the conjugate of the denominator, which is 1 plus the square root of 3. And if I multiply the denominator by something, I have to multiply the numerator by the same thing. So I'll multiply the numerator by 1 plus the square root of 3 as well. I'm running out of space here, so I'm going to start back down below here. For my conjugates, again, in the FOIL process, the outer and the inner will cancel each other out. So I'll just do the first and last. 1 times 1 is 1. Negative square root of 3 times square root of 3, we'll just remove the radical, and I have 1 minus 3 in our denominator. I'll go ahead and FOIL the numerator again. First terms, 1 times 1 is 1. Outer terms, 1 times the square root of 3 is just as 1 times the square root of 3 or square root of 3. Inner terms, 1 times the square root of 3 is also square root of 3. And last terms, the square root of 3 times the square root of 3 is just 3. Working this way, in our numerator, our combined like terms, 1 plus 3 is 4. Square root of 3 plus square root of 3 is 2 square root of 3. And 1 minus 3 is negative 2. And much like you saw with our last problem, we have terms that can be simplified. 4, 2, and negative 2 can all be divided by negative 2. So 4 divided by negative 2 is negative 2. 2 square root of 3 divided by negative 2 is negative 1 square root of 3. So as we talked about with sine and cosine, you'll see a lot of answers that look very, very similar because of these angles that we're using all have those similar values off of our unit circle. So there's our first two. Both were sums for tangents and our simplification process with those fractions and radicals being the denominator of those fractions. Like we have another one here that will simplify at least part way, tangent of pi over 4 plus x. We'll go ahead and write that out as the tangent of pi over 4 plus the tangent of x over 1 minus the tangent of pi over 4 times the tangent of x. Notice we have a variable here that will stay as part of our simplified version simply because we don't know what the value of that variable is. But for the tangent of pi over 4 is the same thing as 45 degrees. The tangent of pi over 4 is 1 plus the tangent of x over 1 minus, and again, tangent of pi over 4 is 1 times the tangent of x. making the point one more time that we multiply before we subtract. So I don't take 1 minus 1 and get 0. I take 1 minus 1 times the tangent of x, or 1 minus the tangent of x. We cannot simplify any further because x is a variable. We don't know what that variable is. So there's our simplified version. 1 plus tangent x over 1 minus tangent x. Number 4, we're backtracking to our work on sine and cosine. Notice that we have sine times cosine, so I'd hope we all agree that that would be a sine. And because of the plus sign here, it's a sine of A plus B, or in this case, the sine of 40 plus 160. And doing a quick little simple math here, 40 plus 160 is 200 degrees. 200 degrees is not on our unit circle, so we'll leave that as our simplified form there, the sine of 200 degrees. Let's see what we have next. Find the functional values and the quadrant of A plus B. Suppose A and B are angles in quadrant standard position. Tangent of A is 12/5. Sine of B is 4/5. Angle A is in quadrant 2 and angle B is in quadrant 1. A says to find the cosine of A plus B. If you recall from our work previously, we're going to find both sine or cosine and tangents. We're going to need to know x, y, and r for both of our angles. So I'll make my little t-chart over here for angles A and B and use our Pythagorean theorem to find any missing values. Tangent of A is negative 12/5. So our tangent is y over x. Oops, let's try that again. Tangent is y over x. Our angle A is in quadrant 2, so that tells me my x value is negative. So I have a negative 5 and a 12 for my y. If we know our triangles, that means r is 13. If you don't know those triangles, you negative 5 squared plus 12 squared equals r squared, and you'll also get r to be 13. Angle B gives us sine. Sine is y over r. So our y is 4 and our r is 5. That will give us a 3, 4, 5 triangle. Angle B is in quadrant 1, so my x will be positive in quadrant 1. So now we have x, y, and r identified for all or both angles. Cosine of A plus B, if you recall, is the cosine of A times the cosine of B minus the sine of A times the sine of B. And now we'll make our substitutions. From angle A, the cosine is x over r, or negative 5/13. The cosine of B is x over r, or 3/5, minus the sine of angle A, which is 12/13, and the sine of angle B, which is 4/5. Making those substitutions straight from angles A and B in terms of x, y, and r. Now here I have negative 15/65 and minus 48/65, or we have negative 63/65 for our cosine of A plus B. We're going to go to our tangent now. I'll go ahead and write out the tangent formula first. Tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. Making our substitutions from angle A, tangent being y over r, so it's negative 12/5. Did I say y over r? I meant y over x. Tangent of B is 4/3, and then I have 1 minus negative 12/5 times 4/3. So you can see we have some fraction work to do. I have these two terms in my numerator, two fractions, so I'm going to combine those. That common denominator would be 15. If I take here, I have negative 36, and I have plus 20, and I'll come back to that. I'll go 2 steps here. I'm going to multiply first, so 1 minus, if I multiply straight across, I have negative 48/15. Sliding down over here, negative 36 plus 20 is negative 16/15 for my top fraction. 1 I will rewrite as 15 over 15. and then minus a negative, we'll make that a plus 48/15. That way I have the same denominator for both of my terms there. So I have negative 16/15 divided by 63/15, or negative 16/15 multiplied by the reciprocal of 15/63. We multiply by the reciprocal, we'll cross cancel numerator and denominator, and we'll wind up with negative 16/63 for our tangent of a plus b. Kind of a question that might require a little bit of thought. Wants to know what quadrant a plus b is in. Well, notice back here that we found the cosine of a plus b. It was negative, so cosine is negative in quadrants 2 and 3. Back here we found the tangent of a plus b. It is also negative, 16/63. So tangent is negative quadrants 2 and 4. They're both negative then in quadrant number 2. So we use the operations or the signs of our sums to find out what quadrant we're in. We're in quadrant 2 because both cosine and tangent are in quadrant number 2. So just to make sure we're crystal clear on that idea, we have that a second time here. A and B are angles in standard position. Sine of angle A is 4/5. Cosine of angle B is negative 5/13. Angle A falls between pi/2 and pi. I hope we would all agree that would put us in quadrant 2. Cosine of angle B is negative 5/13. Pi, or B, falls between pi and 3 pi/2, so that would put us in quadrant number 3, just for reference purposes. Let's start out by setting up our X and Y T-chart here. So we'll find X, Y, and R for both angles A and B. X, Y, and R. It tells us that the the sine of angle A is 4/5. Sine is Y over R. So we have 4/5. 4 for our Y and 5 for our R. That means X would be a 3, 4, 5 triangle. Puts us in quadrant 2, so I'd hope we all agree that X is negative in quadrant 2. Cosine of angle B is negative 5/13. B, or cosine, is X over R. Our X is negative 5 then, and our R is 13, which means our Y is 12. We're in quadrant 3, so Y is also negative in quadrant 3. Y is negative 12. Now, to find the sine of A plus B, our identity or formula is sine A cosine B plus cosine A times the sine of B. And now we'll make our substitutions. The sine of angle A is 4/5. The cosine of angle B is negative 5/13. The cosine of angle A is negative 3/5. And the sine of angle B is negative 12/13. Oh, negative 20/65. We multiply our first two fractions together. Plus 36/65 is going to get me a positive 16/65 for our sine. Tangent, a little bit more work because of the fraction here, so we'll go ahead and expand that out. Tangent A plus tangent B over 1 minus tangent A times tangent B. We'll scroll down here a little bit so we have a little bit better view. Tangent of angle A is negative 4/3. Tangent of angle B is a positive 12/5, and negative 12 over negative 5. And 1 minus negative 4/3 times 12/5. Common denominators again, 15, so I have negative 20 plus 36. I'll go in 2 steps here, so I have negative 48/15 again. Scrolling down here, I'm going to have 16/15 and 15/15 minus a negative is going to make that a plus. 48/15. Then we have 16/15 divided by 63/15. One fraction divided by another gets me 16/15 times 15 over 63. 15's cancel, and we have 16/63. And as we talked about with our last problem here, sine of a plus b, sine is a positive 16/65, so that happens in quadrants 1 and 2. Here, 60 thirds, tangent is positive in quadrants 1 and 3. You can see our overlap is in quadrant 1, so the quadrant of a plus b puts us all the way back in quadrant 1. And of course, we cannot let one of these lessons end without an identity. So we're going to verify the sine of pi over 6 plus theta plus the cosine of pi over 3 plus theta simplifies down to be cosine. Notice we have two sum formulas here, so I'm going to expand each of those out. Sine pi over 6 cosine theta plus cosine pi over 6 sine theta. And then my sum formula for cosine here is cosine pi over 3 cosine theta minus sine pi over 3 sine theta. Both of those angles should look familiar because they come straight off of our unit circle. Off of our unit circle, the sine of pi over 6 is the same thing as 30 degrees. The sine of pi over 6 is 1/2. We don't know the cosine of theta. The cosine of pi over 6 is the square root of 3 over 2. Has to be multiplied by the sine of theta. Moving to pi over 3 is the same thing as 60 degrees, so the cosine of pi over 3 is 1/2. And the sine of pi over 3 off of our unit circle is the square root of 3 over 2 multiplied by the sine of theta. Hopefully you notice here that we have some like terms. I have square root of 3 over 2 times the sine of theta, and I have negative square root of 3 over 2 times the sine of theta. A positive and a negative give us a net of 0. So I have 1/2 times the cosine of theta plus 1/2 times the cosine of theta, and 1/2 plus 1/2 is 1, and 1 times cosine is cosine. So we've verified our identity is true. So there's a look at our sum and difference formulas for tangents, keeping in mind that we have, I'm just going to backtrack here, that we have some extra work to do because of the fraction and because of the radical in the denominator. Don't forget about that multiplying by the conjugate to simplify that denominator to where the radical has been removed. But again, that is our tangent, sum, and difference formulas.